So hi everyone. Before I start, a show of hands. Who here has heard something hyped up about LLM agents? Wow, okay. Big task ahead of me. My name is Šimon Podhajský. I currently work at Pure Storage as a data guy. We sort of do data everything. That's my official title, of course. But sometimes on the weekends and sometimes at work, I have been working with multi-agent frameworks. And there's quite a few of them. And I've accrued enough knowledge about them to try to compare them and sort of present to you what they can do and what they're good for. Of course, before I do any of that, I will talk about what AI agents are and what they're not. And I will also cut down the number of frameworks I'll talk about to just two. Just Autogen, which is developed by Microsoft, and LangGraph, which is developed by LangChain. There's a bunch of others. There's IBM's Bee. There's OpenAI's Swarm. There's a bunch of other insect-related imagery. But these are the two I'll talk about. And sadly, they don't have any insects in them at all. But we'll make do. So what are agents? Whoops. Basically, in the LLM agent idea of things, agents comprise three things. Number one is an individual system prompt, which basically says, all right, when you get an input, here's what you should do to transform it into an output. Here's how you should treat it. Here's what you should do. Number two is they have access to tools. So instead of just OpenAI or ChatGPT hallucinating what the weather is today, they might, for instance, have access to an API that they can choose to use based on the input to check what the weather is in San Francisco. And I'm sorry, if you've seen any YouTube videos demonstrating AI agents, this is the example that everyone gives. But there's any other number of APIs. You can write down text documents. You can query the web. You can do a bunch of things that the tooling gives you. And third, and this is sometimes what gives rise to a lot of the hype, they will typically have an execution environment for the tools. Now, sometimes those tools will be deterministic, and the execution environment just runs the function code wherever it is. Sometimes the agents themselves will write the code that then gets run. And when that happens, it's important to have an environment that's secure to run that code. Both of the frameworks I'm going to talk about use Docker for that, but there's a Czech startup called E2B that provides a more isolated experience, and they have a bunch of cookbooks on their website. So I recommend giving that a check if you want to be careful about security. So you'd think that there's a bunch of other stuff that I should be talking about, right? Who here has an idea for additional properties of an agent? For instance, one idea that I've often encountered is that the agent should be autonomous and out there in the world, responding to events. And that's not necessarily a thing that you have to do with multi-agent frameworks. Plenty often, they just sit around waiting for your input and then processing them in between themselves. That said, some agents, some multi-agent systems can be deployed to be autonomous. If you write, and I will show you a tool that can be sort of used as a Unix tool, even though it's a multi-agent on the inside. But it's not a requirement. Now, you might ask, all right, so I get a system prompt, and I get a bunch of tools. Why do I need more than one agent? And here's why. I identified a bunch of points, but the most important one is honestly the last one. Having a bunch of agents, each with a system prompt and each with a set of tools, lets you segregate the responsibilities. And this separation of responsibilities makes it unit testable. Basically, you can more easily evaluate the system, which, as some of you might have encountered, is the secret sauce of actually driving the LLM-based systems from 60% from the initial notebook where you try out things. By the way, how many of you have tried out things in a notebook? Awesome. And it sort of works. It's basically working most of the time based on the vibes that you try. But if you want to make it work 95% of the time, you typically need an evaluation data set, and you typically need to unit test things. And multi-agent systems basically let you separate out the logic that each item within the system has and test just that, which is much easier than testing a whole system that will check the weather and check online whether there's any attractions open in San Francisco and all that. And one other thing that I wanted to mention is a flow between the agents, right? So let's say that, and this is a system that I'll show because I've made one. Let's say that you have a system that produces cover letters for applications for jobs. Now, you might have a separate system for extracting information out of the job description, a separate system for extracting information out of your resume, and a separate system that writes things and then critiques things. The multi-agent framework lets you dictate the flow between those agents. Instead of just saying, all right, here, central guy, please pick the next flow that seems appropriate. Multi-agent frameworks let you dictate that. So Autogen and LangGraph. These two, and I see I haven't started the stopwatch. These two are basically the leading frameworks right now, and they have a lot in common. How many of you have tried at least one? Okay. Now, an important thing to say is that you don't necessarily need them per se, because as I've just explained, AI LLM agents are pretty simple. You can, in theory, just chain the prompts and then put them in functions, chain those functions, get an outcome. But having those frameworks lets you take advantage of a bunch of things that other people have run into, and basically, get the elegance of people using a framework. Now, of the things that they have in common, I would point out that observability is super nice, and that's kind of hard to get on your own. Basically, if you are just working in a notebook, you already see all the calls that you're going to make. But if you make a more complex system, it becomes a little harder to go through the logs. And if you ever release the system out to the public, oh boy, then you really have to go through the logs with a fine-tooth grind. And that's hard. And both these systems let you log things pretty easily. They both support the transitions, the flow that I was talking about earlier. In fact, LangGraph requires that, hence the graph in the title. Autogen lets you do that, but it can, in theory, you could, in theory, do the anarchy version of things, where you just let a central group chat manager decide who to delegate a task to based on the conversation so far. And they're both testable in a similar way. You can unit test them with something like PyTest or deep eval, which I'll talk about in a little bit. There is a bunch of differences, though. I think that the one I like the most is structured outputs. Does anyone here know of structured outputs? Okay, how many of you have worked with Pydantic or Python types? Awesome. So you may have talked to an LLM before, and you may have asked for a JSON formatted string, maybe, or a JSON formatted output. Structured outputs basically guarantees that the output that you'll get is based on a JSON schema, and it can validate those things, which makes it much easier to plug the output of an LLM into the rest of the system. Honestly, if you take nothing else from this talk, please take this. Structured outputs are awesome. They let you build things that are much more fun to build than you otherwise get. And here, LangGraph is a winner because it has a notion of state that gets passed between the nodes, between the agents, and that state can be typed and validated as a pydantic object. With Autogen, you just get the conversation history, and that's plenty sometimes. It can do a lot of fun things with just conversation, but if you want to plug the system in, if you want to make it narrower rather than wider, it's really useful that you can narrow it down using types. As for deployment, both of these frameworks have a notion of deployment. LangGraph, of course, basically is the cost leader for LangChain, so they will sell you on deploying to their cloud, and it's really easy to do that. But in principle, and again, I will show that in a demo in just a little bit, the whole thing runs in a Docker container. If you can provision an ECS, Elastic Container Service on AWS, or Google Run, or whatever, you can run it yourself. Autogen doesn't really have it out of the box. In the demo that I'll show, have packaged it as a pip installable package, so that's the thing you can do. There's also fastagency.ai that lets you deploy things as a fast API or as a chatbot. So that's also a thing that can be happen, but it's not built in. You have to sort of bend things. And finally, two other things that LangGraph can do. It can run things in parallel in something called super steps. If you chain things so that one output goes to several inputs, it will take advantage of parallelism and actually run those things together. Whereas, to my knowledge, Autogen can't quite do that yet. And it lets you alter the graph at runtime and decompose tasks and delegate them to the same node multiple times, which is really neat for any system that might need to do more than one thing, right? Often enough, when you work with LLMs, you ask them to do sort of multiple things, and they kind of do a halfway job at both of them. And it's really nice to have a system that can separate out the things and have separate criteria for either. Now, before I go to the demo, I will ask for questions if there are any, or if there are any in the Slido. I'll stay silent for 20 seconds. Yes?
With this structured outputs, is there like any other trick than just having the pydantic model defined and then the validation in the pydantic model?
Right, so not entirely. GPT-4o from the latest August release has structured outputs built in. All the previous models had just tool calling, which sort of gets there, but not quite. 4o, I think, is the only model that guarantees the JSON schema will be followed. There is also a library called Instructor, which handles all the retries. When the pydantic validation fails, it will send the failure back and say, look, like you've got the JSON schema, you've got the output, but it fails in the following way. Please fix that, and that usually fixes it. Here, the pydantic support is a little more iffy. I spent a better part of yesterday trying to make it work between multiple different models and found that it makes it really easy to break. If you start doing things simply, it will typically work pretty well. Okay, 20 more seconds.
No Slido questions, by the way.
Yeah, by the way, I love Slido questions. If you're feeling too awkward to speak up, I recommend Slido heavily. If you just go to slido.com and add the hashtag PyData, You can ask any questions you want, and I will never know that it was you. Okay, while I let you do that, I will shift to an example, first an example of LangGraph and then an example of Autogen. Now, LangGraph has a thing called LangGraph Studio, which is basically just a Docker wrapper that will put up the server where the agent will run with a bunch of API endpoints that are kind of neat to have in either way. And it will visualize the system and let you debug things within it. Now here, I actually used a template from LangChain, and the better half of yesterday was trying to make it fancier. And I tried too many things at once and failed. So there's still plenty of rough edges to go around. But basically the idea here is that you have a general purpose research agent, okay? You will start by giving it a topic and optionally a different extraction schema. I will show you what schema I put in by default, and that's the thing you can do. Then it will call the model, the agent, the quote-unquote agent, who will decide, do I want to search for some things? Of the things that I searched, do I want to scrape some of those pages to get more information? Or do I want to fill out the extraction schema with an answer to this question? And then it can decide that it's done and move to the reflect agent. And the reflect agent has a set of criteria that basically asks, is this answer good enough? And if it's not, it will complain. It will detail the complaints, send them back. And the agent will once again research more or rewrite things to actually satisfy the reflection. I will first show you just the what a schema looks like. Let's make it bigger. So if you've never worked with Pydantic, it's really very simple. For LLM use, one thing that's useful for Pydantic is to also add the descriptions of the fields and be sufficiently descriptive so that the LLM can understand what's supposed to be in the field. But mostly the magic is just the type hints, the string or list of strings, which tells the Pydantic that when the object is instantiated, it should complain if it's not a string or a list of strings. And this is, I've made a slight change to the original template that just uses this to populate the answer. So here, I'll just demo. I set this up so that it's easier to do go-to-market analysis, which, if you're unfamiliar, as I was a month ago, it's basically a process of making sure that when you're trying to sell your startup product, you know how to do that. So let's say I'm a startup that converts children's screams into images and puts them on t-shirts. And help me sell this. So here, you'll note that it actually stopped. It's not going 100 miles an hour because within LangGraph, I can do something like checkpoints. I can interrupt before the agent model is called or after it's called. And so that way, you don't let the model or the multi-agent system run away and waste all of your OpenAI credits. But you can if you want to. So actually, I'll click continue. Now the tools are running through the search, and the agent appears to have actually designed the specific steps for the go-to-market strategy. Talk to parents, have a strong online presence, social media, influencers, promotions, marketing strategies. It's not terribly specific, and this is something that you'll have to work with if you want to make a system that's actually useful, because this is very general. Like, it's supposed to also help you search for fun socks and figure out how to design them by the same measure. But if you actually work on the prompts, you might get to a useful place. So here, it's outputted the specific message, specific steps. It's now moved to reflect. The reflection is actually happy, I believe. It identifies the industry. There's a good summary. The steps target a niche market, which I guess this is. And it's aligned with current market trends, which I think is a hallucination, because I'm not sure there's any market. I certainly hope there aren't any market trends for this. So I believe that since it's answered with a satisfactory answer, it went to the end and concluded. And now I can go to an input, to the output, and see whatever the JSON output is, which is what we've already seen. So that's one nice thing about working with LangGraph. You'll get all this. It's even when it tries to, when it runs into errors, which I think I might have here from earlier. As some of you might be familiar with pydantic validation errors, this is exactly what happened here. It can automatically open the trace in Langsmith, which is associated with LangGraph, because LangChain just tries to dominate the entire market of Lang things. And here you can basically run through each step, see what the inputs and outputs were, see what the pricing on the Anthropic thing was, how many tokens were taken up. It's a fairly neat system. Now for the cover letter creation, I might be out of time, aren't I? But let me take three minutes anyway. All right, so say again?
That's fine.
Okay, yay. So for the cover letter, this is more of a Python package, okay? It's sorry about this. The basic notion here is just that you define in code what the transitions are between speakers. You instantiate objects that you've prepared before. The writer object, for instance, has this whole prompt of how to be a good cover letter writer and not sound like an LLM writing a cover letter. And you define the transitions between the speakers. So from the client, which is me, you go to the JD ingester, the job description ingester. From there, you go to the researcher of companies, so that you can have specific details that you've researched because you care. From there, you go to the resume reader, and then the writer and the critic can go between each other until the critic is satisfied. And you'll notice that this is not a DAG. This is not a direct acyclic graph. There's allowed to be cycles there, which is neat because this means that you don't have to go back and forth with ChatGPT. You can just let it roll with the criteria that you've set aside before. Now, this I've made into a command line interface. So I could just run make cover letter and provide it a markdown job description, a JSON resume, and maybe a file with personal motivations, and then let it run for about a couple of seconds. Since it's a lot of tokens, it takes a while. You will spend about 50 cents on this. But you can see that it's a little less fancy than LangGraph. This just identified the job description items from there. And it sort of goes on from there. I think this is boring, so let's cut it short. But basically, the idea is just that you can also have something that is not fancy. You can have something that just runs on the command line. You can have something that is pip installable, and that's OK. And you can do that easily with Autogen. Last thing I should say is that out of this comparison, Autogen is not really coming off well. And that's because they just released their major version and I wasn't able to, or actually, they are about to release the major version and I was not able to test it. But there are some features that should make it a little easier to work with. There's also Autogen Studio, which makes it more easier to graphically interact with things. So yeah, if you have a task where you go back and forth with ChatGPT several times, and it's usually the same things, give this a try. Give a try to automating the things that you would say with multiple agents and see if you can do it. And if you can, it turns out to be really neat. And if you can't, you will have learned something. And that's also what I hope you've taken from this. Thank you for your attention.